You have had a few days to get really excited by new developments in tech. And I'm sure that there have been a lot of conversations about data science and AI. And now maybe it's time for us to bring it down a little bit. There's a lot of science fiction, and there's a lot of misinformation in this space. And sometimes, if we don't take a moment to think simply about it, we might lose the forest as we're getting fascinated with the trees. So this talk is about simple things that I notice are quite often forgotten. And if we forget them, we're in danger of building unsafe and unfair machine learning and AI solutions. So let's talk about some of these omitted things, a few nuggets to really bear in mind as you are developing AI systems. First things first, don't be distracted by science fiction. In the history of this field, for a lot of its start, it wasn't that useful, let's face it. And so the way that you would get grant money to persist in it is to make appeals to science fiction. And today there's a lot of sales and marketing that's also driving that hype and those robot-y buzzwords. So here's what I say to you. Forget the robots. Robots are, if you want to think about it, a sort of pet rock, right? A rock with a pretty face drawn on it. That doesn't mean it has a mind. It doesn't mean that it thinks. So if you're going to use a pet rock to get students excited about geology, make sure that your lesson sticks to geology and doesn't stray into pet rock psychology. And similarly, if you're going to talk about AI and you're going to paint a face on it as a marketing ploy, be careful and don't make that step over where you start to think, because it kind of reminds you of you a little bit, that it is anything like you. AI is not a person. It is a tool. It's a useful tool. So what is it actually a tool for? Because that's where we'll see both the promise and the danger of this tool. Computers are tools that take information and convert it to other information, right? Inputs turn to outputs via some recipe in the middle, via a model. And the difference between traditional programming and machine learning simply comes from where that recipe in the middle comes from. In traditional programming, what do, developers? You know this. You communicate with the universe, am I right? You meditate on the task. You think really hard about how to convert those inputs into those outputs. And then you must handcraft that recipe with explicit instructions. That's how you do it. With machine learning, you instead express what you want, not with instructions, but with examples, with data. So you say, here are a bunch of, maybe you're doing a task that's classifying cats versus not cats. Here's a bunch of cats, here's a bunch of not cats. Now you, machine learning algorithm, you go figure it out. That algorithm finds patterns in the data and stitches those patterns into a model or recipe, and that recipe then performs the same kind of function as what that recipe that the human developer would have written do. And so if you think about whose job machine learning and AI actually automate, whose is it? It's a tool for writing code. So it automates some part of the software development process, actually. Though don't worry, software engineers are not going out of fashion anytime soon, because there's going to be plenty of tasks that are not appropriate for AI, and there are also going to be plenty of things for you to do in the AI process to get that algorithm to play nicely with the data in the first place. So it's a tool for writing code. Now, next nugget to stay safe, now that we've got that, and we're going to stop anthropomorphizing it gratuitously and talking about machine learning learns all by itself. No, it doesn't. It's a tool that someone used to get their task done. Let's play a little game. So we talked about a cat-not-cat classifying task. Let's have you be the classifier for me. And to wake us all up, I'm going to ask you to shout at me. So I'm going to say the number of the image there, and you're going to shout at me, cat or not cat, right? Wake yourselves up a little bit. So number 1, cat. You can do better, you can go louder. Number 2, not cat. Number 3, cat. Number 4, cat. Number 5, not cat. Number 6, big cat is not an allowable answer. Maybe cat is not allowable here. Is it cat or is it not cat? The simplest classification task. The internet tells me stop talking about cats and not cats. Google, we're bored of this. See, this is supposed to be easy. Why is it so hard for you? You begin to see the problem. There's no one right platonic answer for this. The right answer depends on the purpose of the system. It's whatever the leaders, the decision makers who created the system needed the system to do in this situation. So if we don't have any leadership here, who knows what we're supposed to do? I'd better fill those big boots, right? Let me step up. I'm going to tell you that the purpose of this system is to be a pet recommendation system. And so when it says cat, the animal has to be from the cat family and in its typical adult form, safe to cuddle. Let's try this again. Number 6. Not cat, and if you're still saying cat, please take out more life insurance. Not a kind of pet I would recommend. So here's the second nugget. Please remember that the objective, the goal for the system is subjective. What the correct behavior and the correct answers are depends on what people needed it to do. And this has a few consequences. First things first, any notion of the AI is going to get it all by itself should feel even more ridiculous to you at this point. And you should see that behind all these systems are the wishes and wills of the humans who brought them into being. And you can't separate this technology from the humans that created it. And also, the other thing that you should know is that there is no one right answer. And you can't expect a system built for one purpose to just be okay to pick up and plug into some completely other thing, and then you expect it to do what you need. If I built this system to recommend in such a way as to say that that is not a cat, and you're building a system where your behavior that you're looking for is to classify that tiger as a cat, you cannot just pick up my system and use it. Things are going to go wrong. And I see a lot of folks forgetting this. It really depends on what the people needed it to do. So never forget the human side of this. And it starts with that objective being subjective. Now, next question for you. Which do you prefer? A reliable worker or an unreliable worker? Which one is better? What am I hearing? Talk to me. I hear reliable. I hear murmurings here of reliable. You want reliable? That's a better worker? Watch out. I would say that you should be shouting at me that it really depends on the quality of the decision maker again. It depends on the quality of the person giving the instructions, setting the objectives. Because if you have a wise decision maker who can carefully think through what they're asking for, then you want the reliable worker who actually delivers that, tries their best to give that good decision maker what they asked for. But what if you have a complete idiot in charge? Then the unreliable worker is your saving grace. The unreliable worker won't scale the idiot up so fast. The unreliable worker will prefer to do something else, sit on the beach, play with their kids, play video games, instead of carrying out exactly what was asked for. Machine learning and AI, that's the ultimate reliable worker. These things don't think for themselves, they don't think at all. They just try to optimize towards whatever objective you, the human, set for them. And so, as a result, what they're going to do is they are going to amplify one of two things: the intelligence of a wise human decision maker, or the stupidity of a foolish human decision maker. Humans, on the other hand, are relatively unreliable. And they tend to be unreliable in all manner of different directions. They don't scale so well. And that's why getting tasks done with a collection of humans, when you have fools in charge, tends to be a little safer. But you don't get such good results if it was a good objective that you actually would have wanted more efficient, more reliable folks on. So watch out for that. And please think about the quality of the human decision makers behind this. That really, really matters. And that's the piece that doesn't get addressed enough. There's too much talk of this sci-fi stuff, of this autonomous stuff, that we actually forget this human side. And then if we do talk about the humans, we're talking about the builders and the developers. That's you guys, and that's great. But people make it sound like it starts with you. It actually starts somewhere else. It starts with purpose. It starts with leadership. Maybe you do that role as well. But it doesn't start with the developer. And if you are being set to automate some system that is based on foolish goals, maybe you should think twice about taking that project. Next, what is the actual essence of the danger of AI? That specific piece that is the AI danger piece, not the technology danger piece. I mean, if you wanted to disrupt markets, if you wanted to create complex systems you can't get rid of, mess up social relationships, you could do all that without machine learning and AI. I mean, please don't do it with or without AI. But that is the nature of technology. Technology causes change. Change can be disruptive. What's the specific AI piece? Let me show you. When you are automating a task the traditional way, you have to agonize over every little instruction. And maybe not you personally, maybe you're taking a package that someone else has created, but someone from our species has to have thought about each and every little line of code there. And okay, you know bugs creep in there, someone was drinking a beer when they wrote it. These things happen, but at least there was some tiny bit of real estate from our species into each bit. That is the part that goes away with machine learning. Instead, it now boils down to 2 lines. Optimize this objective on that data set, go. Now, it looks like you're actually writing a lot more code, and you're huffing and puffing, and you're fighting with all that TensorFlow boilerplate. But actually, all that stuff is wrangling bad tools. And I can imagine a future one day, eventually, maybe quite far away, where these tools become so easy to use that you are able to get it all done with effectively 2 lines, 2 instructions. This data set, this objective, run. Now this is really exciting because now you can automate tasks without thinking too hard about it. Before you had to come up, maybe to automate your task, you needed to come up with 10,000 lines that you'd have to think about. Now you just got to think about 2. It's great for small personal projects, but what if the project actually affects the world, and it scales, and it affects a lot of people. This is a thoughtlessness enabler. And thoughtlessness at scale, where it touches a lot of lives, is a hazard. And are you really going to put as much respect and care into these 2 lines as you would have into half of your 10,000-line project? Or are you just going to shrug and go, hey, I'm not even going to open that data set. Let me just point it at that folder or point it at that database, data warehouse, and hey, let me now think about my objective. Accuracy sounds good. F-measure sounds fun. Whatever. Off we go. Hit run. And maybe you've spent a lot of time sort of huffing and puffing and getting it all to run, but that's not the same thing. That's like if we use the analogy of monkeys on typewriters writing Shakespeare, that part, my friends, is getting the monkeys to sit still in the chair. That's not thinking about the nature of Shakespeare or why we even want the Shakespeare written. And these are the parts that we really need to respect and think very carefully about. The power and beauty of this AI stuff is that you don't need to know the instructions yourself to automate the task anymore. You don't need to handcraft them. That's great, that's amazing. That means we can automate the ineffable. But it also means that we now need to start caring and thinking about where we are pointing that leap in technological progress a lot more. We don't have the same brakes on the system as we used to. So, nugget number 4. We need to learn how to wish responsibly. If you think about this whole space, it's a little bit of a proliferation of magic lamps. There's some commonalities between how those be careful what you wish for stories, how those wishes are phrased, and the change in getting your wishes carried out by a machine learning system, moving from instructions telling the genie exactly how to do things to here is what I want. That's the direction you go in. And all those be careful what you wish for stories, like the whole point of them is that we're not always, as a species, that wise about thinking through what we've asked for. And then problems happen when exactly that is delivered. That's a bad habit that used to not hurt us that much, because bad decisions and bad decision makers were self-limiting. Sure, you'd do a little bit of harm, maybe to your immediate village, but that's where it stopped. Unless you were a king or a pope or something like that. Whereas today, with the democratization of this stuff and the ability to really scale our wishes, it really matters that those in charge, those leading this stuff, develop the skills to wish responsibly. And it's really important that you all, whether you are in charge and you're leading, or whether you are carrying out and building towards these objectives, think about what these objectives are saying. And you develop the skills to check what you're asking for and make sure that if the letter of the wish is delivered, that the spirit will also be delivered. That it's not possible to give you the spirit, it's not possible to give you the letter of what you asked for without the spirit too. So let me give you a few examples. These are intentionally humorous examples where a person, his name is James Fridman, and you can find him on Twitter. There's this handle at the bottom there. So he will Photoshop photos that people ask him to edit for them. So here they've asked, can you please edit this picture so that my brother and I wear the same t-shirt? And he delivers. Here's another one. Can you please adjust this picture to make me look as if I am holding that cliff? Ta-da! So James does this because it's funny. But he's showing here that these folks didn't do a very good job of asking. It wasn't ironclad. Now, you're going to have similar kinds of problems when you work with AI systems who will, like James, fail to interpret what you thought you were asking for and give you instead what you did ask for, which is why you need to level up your skills in asking. And let me show you another unintentionally humorous example, this time of an AI system. If you want the humorous examples, there's this really great website, and there's a new book out based by the author of that website, but you should check it out. It's AIWeirdness.com. It's great for a laugh. But here's a different thing. It's unintentionally humorous. So here, some researchers at DeepMind wanted to create a system that navigates its environment, that runs efficiently, and they forgot to mention the arms. So what you get is an arm-swinging idiot, right? You said, walk efficiently, ta-da, job done. And in fact, I really love this quote by AI researcher Alex Erpin. I think it applies to more than just his area of deep reinforcement learning. It applies to all of machine learning. I think it's a good rule for living. I've taken to imagining machine learning as a demon that's deliberately misinterpreting your objective. It's actually a productive mindset to have. Yes, please imagine that these systems are going to try to give you the most perverse version of what you asked for, and make sure that you can live with that. And if you can't, then think more carefully about what you're asking. And if you want to get really advanced with this, what I'm saying is start simulating your incentive functions, your reward functions for these systems. Start finding out the ways in which things can go wrong if your system performs according to the metrics that you specified. Please remember, this stuff isn't magic. There's no mind reading here. There's no interpretation. You're not going to get what you hoped you were asking for. You're going to get one of two things. Either nothing, because your ambitious performance metric wasn't cleared, it didn't pass testing, and then the whole thing got mothballed, or your performance is delivered, and you're going to get exactly what you asked for. So please watch out for that. Oh, and by the way, I hope you'll indulge me in this talk. I'm using machine learning and AI somewhat interchangeably. I know they're different if we're going to be academically strict about it, but I kind of give up. Industry uses them interchangeably as well. And quite frankly, my favorite definition of the difference is this. If it is written in PowerPoint, it's probably AI, and if it's written in Python, it's probably machine learning. Yeah? OK. Cool. So AI is not magic. It can't read your mind. Please test rigorously and always build safety nets. And because you shouldn't trust anyone, you shouldn't trust the system, you shouldn't trust your human workers, and you shouldn't even trust yourself, please build safety nets just in case, even though you tried really, really hard to wish responsibly, just in case you messed up. So build those safety nets. And build them in advance. Don't build them after the fact. Don't start building them after the fact when your first problems start showing up. So here's an example I like, also from Twitter, is this fellow, BJ May, complained that his smart locking system on his front door locked him out of his house because the system was trying to protect the members of the household from Batman. Now, this was just a funny, fun situation, because actually BJ May could get back into his house. There was he could use a pin pad and put in a code, and then the door unlocks. So he's not permanently locked out, it's just a humorous situation. The reason that that story ended okay is that the developers had considered the possibility that issues could crop up, and they built that safety net in. What if there's a mistake? What if there's a problem? Well, let's have this backup way that the person could get back into their own house. If, on the other hand, they had never even considered the possibility that a mistake was possible, maybe that house would permanently be locked. And that would be a huge problem. And so building these things in advance is really, really important. One of the most dangerous errors in the whole AI space is forgetting that mistakes are possible. The reason that you're appealing to these technologies is that you couldn't come up with that simple solution and write those instructions yourself. So then you ended up having to get them learned from data. That's probably because the task was a little bit too complicated. And so here you are working with complex tasks. You shouldn't expect perfect performance. You should expect mistakes. Maybe the performance will be better than what was previously possible when you did it by hand. That is not the same thing as perfect, so please watch out. And please think like a site reliability engineer. Site reliability engineers, they work on keeping large-scale systems reliable in production. And I need you to start borrowing their mindset, not over-focus on that prototyping phase, training machine learning and AI models, but also think about how this is actually going to work in production. And think not only like a site reliability engineer, think also like a user experience designer. One of the suggestions that I have in practice for developing these things is before you train the system, create some simple benchmark and some simple code that does the task in a bad way, fine. So that's standard practice, you know that one already. But then start designing the interface once you've got this thing in place, and plug it into that interface first before you go and train this complicated system really carefully. And think about the actual experience of using that interface. Try use it yourself. Try label in that cat not cat task, try label some photos yourself. When you start seeing that you're having a problem with where to put tiger, you shouldn't expect that the machine learning system's just going to figure it out. That's on you. So think like a designer and think like a reliability engineer. Now, next part. We've said that the beauty of AI is that you can automate things where you can't express the instructions. You can automate the ineffable. Wonderful. But then, do you really expect that you're going to open up that black box and read the instructions that it came up with and understand them perfectly? I mean, if it were that simple, if it were such low-hanging fruit that you were automating and you could say in one sentence how it works, then you wouldn't need to appeal to data in this whole convoluted process. You would have just written that one sentence as code and off we go. And in fact, that would be much easier to maintain in production. If you can code it up by hand, do that. Folks ask, how do we make our company more of an AI company? And I say, don't worry about that. Don't strive to do AI. Strive to solve good problems. Try to solve them first without data. And if you can solve them that way, good on you. That's going to run better in production. It's going to be a simpler system that's easier to run in prod. Now, if it fails the traditional way, then maybe data will help you out. Then maybe you need this stuff. But then don't expect that you'll be able to read those instructions. Maybe you will. Maybe you won't. Maybe it'll be a case of, sure, it's a readable linear model, but maybe it's so long, there's 1,000 lines of instruction, you've forgotten them all by the time that you've started reading it, because it's boring and it's all written as coefficients and variables. Maybe that's not easy for you to read. Maybe it's neural networks and that's a complete jumble in there that you can't make any sense of when you read it. Okay, how do you trust such a system then? How do you know it's working? I'd say treat it the same way as you treat a human worker. You don't know how a human student's brain performs calculus, for example. Neuroscience doesn't know that either. And you're not going to check a calculus student's ability by taking a scalpel and poking around in their brain. How are you going to check if they can do the task? You're going to design an exam for them. And that exam has to be appropriate. And if they pass that appropriate exam, then you trust them. And the bigger your trust issues, the harder you make the exam, am I right? That is also how you should approach AI systems. Test everything, and test on appropriate examples. Make the exam hard enough, and make sure that you've been very careful with your statistical testing. And when you have humans doing the task, test them as well. Test everything, your humans, your machine learning systems. So I work for Google Cloud, and sometimes customers will ask, how do we know if we can trust your machine learning APIs? To which I, probably letting down my marketing team, say, don't trust it. Why would you trust any of it? Test it. When you want to pick it up and use it, send examples through it on one end, see what comes out on the other side, and make sure that you like what you're getting. And all this explainable AI stuff, all these tools for explainable AI, they're not actually about opening up that black box and reading that mess of instructions. What they're about is doing the same thing that you would do with a human worker. Send inputs in, see the outputs on the other side, and do analytics on both sides and look at what is happening. What kind of inputs do we get mistakes on? What kind of inputs do we get success on? It's about thinking about that exam. And it's about testing carefully. That's the part that keeps you safe. Now, here's another very simple example involving my two cats, Huxley and Tesla, and bananas. Imagine that we are training our system, and there's thousands of images where you get, for each placeholder here, you've got thousands, so imagine 7,000, not 7. So we train it, cool. And then we have a test set, amazing. And then, ta-da, the machine learning system perfectly classifies Huxley and Tesla for 100% accuracy. What's the problem here? The problem is that we have used the same photos in the training set and the test set. That is like giving a student some homework problems to study from and then putting exactly the same problems on the final exam. Of course, that's not going to be a good exam. The student can beat that exam by memorizing. Or in fancy AI talk, that's overfitting, where the system memorizes the noise in your data and then doesn't learn anything general about performing the task beyond. So how do we beat overfitting? How do we catch it? The same way as you do with human students. Give them an exam with stuff they haven't seen before. That's what it takes, and then you see that they actually have no idea what they're doing because they can't beat it by memorizing. Which is why number 7 is always use pristine data for testing. Don't skimp on this. And in order to make sure that you have pristine data for testing, what does that mean? You've got to split your data in the first place. You've got to make sure that you actually set some clean data aside that the system could not possibly have memorized. Computers are really good at memorizing stuff, right? That's why we want them for processing data and not me, who's going to forget after I've started reading a spreadsheet. I'm like 20 lines in, I've forgotten what line 1 was. Computer doesn't do that. They're really good at memorizing. Don't let them win at exams by memorizing. Always split your data. So if this is such obvious advice and you believe me, then I ask you, why are you not splitting your data at the infrastructure level? Why is this not completely mandatory everywhere on every data science team? It should be, so please do it. Now, imagine that the system had instead given you perfect accuracy on your test set, or very good accuracy. And you're like, great, this was a system where we're supposed to classify which one is Huxley and which one is Tesla of these cats. And now what I have is a Huxley-Tesla classifier. And then you might even talk to the media, and then they write a beautiful article that's like, machine learning learned to separate Huxley and Tesla. It knows. Look at these cognitive words that come out when we talk about our pet rock in the wrong way. It knows which one is Huxley, which one is Tesla. Avoid jumping to conclusions. The only thing that we can say here, accurately, is that on the test data, the system performs the task at some performance, and maybe we are happy to launch it. It doesn't mean that there's any understanding. See these cognitive words again? That there's understanding of Huxley and Tesla. In fact, why don't we look closer? What if in all the photographs where we had Huxley, there was no radiator, and in all the photographs with Tesla, there was a radiator? And maybe the system exploits that pattern and simply looks for those grills, and if it finds them, it outputs the label that it calls Tesla, which means nothing to it, by the way. It's just some made-up letters. And whenever it isn't there, out comes Huxley. And then, when we look closer at the test set, that was true as well, because maybe in this apartment, Tesla always liked to hang out next to the radiator, and maybe when I photographed her, she was always there next to it, and it was always in the background, and Huxley's never by the radiator. The system will perform well for the task that I need it to do, but it doesn't understand anything about the nature of these two cats. That term doesn't even make sense for pet rocks. And we cannot expect it to work outside of the type of data where it was trained and tested. So please make sure that the data that you are using are appropriate and representative of your task and where you need it to perform correctly. I tell machine learning engineers at Google who are going near the space to pretty much tattoo this sentence on themselves if they want to participate in machine learning and AI. The world represented by your data is the only world that you can expect to succeed in. So please make sure that you think really carefully about what data world you're dealing with. At the end of the day, machine learning turns patterns into recipes. If you put garbage in, you get garbage out. And I hear a lot of funny rhetoric about data and data science. It sounds like the word data is being pronounced with a capital D. And it's like, oh, you just have opinions, but I have data. I have facts. That's better than opinions. I think it would be helpful if we remembered that data sets and textbooks are very similar things. A textbook is actually a data set, and if we make the textbook electronic, then it literally is a data set. And a data set is a textbook for you and your system to learn from. Both textbooks and data sets are created, written, authored by people, by humans. They come from humans. And they are not actually reality. They are a filtered, small snapshot of what a human thought was interesting and worth paying attention to. So you know that way that we laugh at people who say, it's written in a book, therefore it must be true? Why don't we laugh at people who pronounce data with a capital D in that same way? Oh, it's in the data, it must be a fact, it must be perfect, it must be true. It must be everything we need. No, it's made by humans. And if those humans are a bunch of biased jerks, then shouldn't we also expect the systems that are trained on that information to pick up the same biases? There's a lot of talk about bias in machine learning, and there are a lot of different definitions of bias. There's the statistical bias, which is not this. Statistical bias is just where results are systematically off the mark. But the bias that people are getting really concerned about in the AI space is this one, algorithmic bias. And definition from Wikipedia is here. This occurs when a computer system reflects the implicit values of the humans who created it. I want to ask you, is it possible to create any technology that does not reflect implicit human values? Does that even make any sense? Technology comes from us. It reflects us. Now, that does not give us an excuse to be jerks. We should strive for fairness. We should strive to do our best by people. And we should remember that data comes from humans. It matters who the authors are. So you hear a lot of words on AI bias. I want to give you instead the Hemingway lecture. A short story in 6 words, like the famous one by Ernest Hemingway. Algorithmic bias, inappropriate examples never examined. This happens when a teacher takes a textbook, a data set, and gives it to a student, human or machine student, without thinking about who wrote that textbook, what's in that textbook. This teacher doesn't even bother to open the textbook. Just says, the textbook is in that folder over there. Go learn it. Everything will be fine. What kind of teacher does that? Please don't be that teacher with these systems. Open your textbook with analytics. Take a look. Make sure that you see what's in there. This is really important. And make sure that you also think about who the authors were and what the purpose of the textbook was. Just because you have a book doesn't mean that your student will learn the task that you need. Like this idea that you've got a data set, therefore you're going to win, is like running around saying, I own a book, everything will be great. I will learn how to be an architect from whatever book it is. Then you open it up and you find out that it's a book of fairy tales. Please, please open those textbooks with analytics. And then finally, this whole thing was a gentle example of bias. I, the person who took these photos, I was brought up in a way to find cats to be a pet that is appropriate. Imagine if I had grown up in a society on a planet that thought that cats were evil, inappropriate pets. I wouldn't even have a data set like this. I found it appropriate to photograph them in my apartment and to make a system of this kind. Those are gentle biases, but it might not even occur to me that someone might do it in a different way. And it's very hard for me to get out of my own head and to think about what I'm doing and whether it's appropriate. And if it's hard for me to step outside of myself and see things from other perspectives, then maybe to keep myself safe, maybe I shouldn't rely on my own ability to step outside myself and identify my own biases. Maybe what I should instead do is seek other perspectives. Have other people look at what I'm doing and think about issues with it. And call out the parts that I'm taking for granted. If I want to strive for fairness, I also have to strive for awareness. And there's only so much self-awareness that one can bring to it. Really, the cure and the key to fighting AI bias is bringing a diversity of perspectives. See, if the author of the textbook and the teacher who opens it up and checks whether it's appropriate are the same person, is that person going to understand that they are a prejudiced jerk? Probably not. That's why we need more diverse authors, and we need more diverse people checking the textbook, more diverse teachers, analysts. Which is why I like to say in this space, diversity is not a mere nice to have. Diversity is a must. It's how we stay safe. So those are my 12 tips for you, 12 nuggets. And if you follow them, and if you keep them at the top of your mind when you're doing all that stuff and you're going into the details, you keep these larger things in mind, that is how you will build safer, better machine learning systems. So I hope that you're inspired by the power and promise of this technology. But I hope also that you will strive to build a safer, brighter AI future. So let's build that together. Thank you.